Okay, can you hear me?
You are now.
Hi, Pradeep. We can hear you.
Hello everyone. I, I hope I am audible.
Yes, you are.
Okay. So welcome everyone to another day of Linux App Submit. Today we are joined by Mr. Pradeep Sharma. He is the founder of Invite Labs and he helps other developers uh, grow with the help of open source projects. Today he will be talking about building and distributing Linux desktop apps using Electron. Also, if you anyone has any questions, they can post those questions in the shared notes over the users panel.
Okay, great. So welcome everyone. Thanks a lot for joining in. So today we are going to talk about building and distributing Linux desktop app. And we are going to talk in the context of Electron framework. So before we move forward, a quick intro about me. I created a desktop app called Developer ID, which is a privacy focused note taking app available on Linux, on Windows and Mac. I founded Invite, which is a community of remote developers. 15,000 developers are member of this community. It was started in 2016. I'm also a producer of a developer conference, Git Commit Show, which is a completely online developer conference and completely non-profit. Started in 2019. I also contribute to some of the open source projects, and I keep building some stuff to teach people about full stack development or related to security and cryptography. And I have trained some students as well. And I love to play chess. So if you also love to play chess, do ping me after this talk. So this was a quick intro about me. The relevant experience that I have for this talk is building Developer Diary. So Developer Diary is a privacy focused note taking app. And I hope everyone can hear me. Okay, cool. So Developer Diary is a privacy focused app for note taking and especially made for developers. So if you have any thoughts in your mind, any solution that you are planning for your problem, you note down quickly using a shortcut in this app. And when you are done with your work at the end of the day, you note down things what you did in your day and then just move on with your personal life and close whatever work that you have for your professional work. And this app is available on Linux, Mac, and Windows. I created this using a framework called Electron. And I have released more than 30 releases for this and also the product which was predecessor of this app. And I started working on Electron apps in 2016. So I have built apps using Electron 1.x to what current version we have in Electron 13.x. So that's a long journey, and in this long journey I have faced many challenges related to building the app as well as maintaining the app. So I have some experience which can be relevant for you to speed up your development and to avoid the problems, avoid the challenges that I faced. So before we dive into this talk, I want to ask this question to every one of you. So the first option is, have you used Electron before? So you will see the poll option. If you can answer yes or no, that will give me a better idea how to proceed. Okay. Okay, people are typing in chat. You can also, I would prefer if you can share via this poll option where you're asked yes or no. Okay. So right after you have answered this question, I would also want to know if you have which Linux distro have you used in last 2 years? And you can share with me, is it Debian, is it Fedora, Arch Linux, OpenSUSE, or anything else? If it is something else, please share that in chat. Okay, so 56% users have used Electron already. Cool. And the second question is on the screen. Okay. Okay, cool. Very good. So I think almost half of the people have used Electron and half of them haven't used it. So what I will do, I will move on to the next slide. Alice, can you enable? Okay, yeah. Cool. So Debian is, we have received the results. Debian, 42% people have used Debian. And then on second, we have OpenSUSE and Fedora, then Fedora and Arch Linux. Okay, great. Thanks a lot for sharing your answers. So because half of the people haven't gone through, don't know about Electron, I will introduce Electron. And even if you have used Electron before, it will be kind of refresher for you. And I won't spend much time here. So let's quickly jump into the introduction of Electron. What is Electron? It's a framework to build cross-platform desktop applications. And so you can build application for Linux, for Windows, for Mac, and also on Linux you can build for all the distribution that we have for Linux. Now, what do we have under Electron is Chromium rendering engine and Node.js runtime. Those two things provide us the whole experience of building cross-platform desktop application. Okay. Now, as a developer, when you are using Electron, you can code using web technologies such as JavaScript, HTML, and CSS. And that's it. That's all you need to know. And with this knowledge, you will be able to build apps, and you will be able to build apps for all the Linux distribution platforms. Now, let me show you a quick glimpse of how does a hello world in Electron looks like. So look at the first file, yellow file. So here you are importing app and browser window from this Electron framework. And then you are saying when our app is ready, create a window that you see, which you can interact with this GUI window. And then what does create window means? You can see that it means creating a browser window, accept some options, and then it says to load a HTML file, right? And how does a HTML file looks like? We are just saying hello world, that's it, and keeping the background white, and that's it. That's your hello world. That's your first application using Electron. It is that simple. and you want to build more pages, you know HTML, you just put your stuff there, and there you have a UI ready for you, which will be available in all the distributions of your Linux. So that is the power of Electron. Using simple JavaScript, HTML, and CSS, you can create wonderful applications, and you do that quite fast. So your development time is reduced. You can get support from many people who know web technology, which is many people. You don't need any specialized skill for that. And learning Electron.js is also not hard. You can simply go to this electronjs.org website, their main website, and you will get to know how to build app. Their documentation is amazing, and that I would suggest is a good starting point to learn about Electron. So you will learn about that, and we won't go into detail, but you have a basic idea how to build an Electron app. Now we are moving to the second part of this talk, where we talk about, now that you have coded your Electron application, how do you package that? How do you package that as a file which can be installed, like a DApp package or maybe a RPM package or any kind of file file that your Linux distro supports? So how can you package this app? This is what we are going to discuss in this slide. And there are multiple ways to do this, packaging your Electron app, but the most reliable way that I have found, which works for me every time, is Electron Builder. Electron Builder is another library which is built for Electron applications. Using that, you can package your applications into your desired format, desired installers, or desired distribution file formats that you want to. And you can do that on your system itself. If you choose one Linux platform, let's say people said Ubuntu is one that they are using, most of us, then you can build package for all other Linux distributions, like you can choose Arch Linux, OpenSUSE, or FreeBSD, anything, and you will be able to build that from your own Linux system. Now, how does it look like when you package app? What code do you need to run? And this is what I'm showing here. So package.json, as you might already have already knowledge of, is a dependency management file for node related applications. And this is exactly what Electron uses to manage its dependencies. And there you define simply this dependency Electron builder. You define the version, and then you define a key value pair for build. Now this key build will be used for configuring your Electron builder. And let me quickly give you what options do you want to have to pack your Linux desktop application. So first thing is SR packaging. So SR is you can say kind of a packaging or a compression format that you use, and you can do without SR format as well. But in my experience, I have found this SR format is more suitable, and you won't run into any kind of problem when you are using SR. If you are not using SR, then probably you will run into some problems, which I had. But when I used SR format, then I was not running into any problems. Was to define an app ID for whatever distribution that you are distributing to. They might need this ID. It's an optional optional field. You don't need you don't absolutely need it, but defining it, I have seen, is it's good to have. Then the most important key thing that you want to mention in this configuration is this Linux key, which is an object. In that object, you define Linux first. Linux, when I'm saying Linux, I'm telling this Electron builder that build or pack this app for Linux platform. You could have had Windows, Win, and for Mac OS, Mac. But we are not talking about them. So for now, let's just focus on Linux. And inside Linux, you want to specify what target do you want to pack this this app for. Okay, and you can choose any of these targets that I have shared here. You will find all this documentation on Electron Builder's documentation page. But just to give you an idea what kind of package targets are supported, it's app image, snap, dab, RPM, FreeBSD, Pacman, P5P, APK, and many more. So you get an idea that this is supporting almost all the Linux distributions that we have. So you can build, you can create that file which you will need to install your app in different Linux distributions. Okay, so that was about target. You can also choose the architecture. Do you want to build for 64-bit or 32-bit? For now, we are not going into that because usually we want to build for 64-bit. That's what most systems are currently, but you have option to build for older versions, for older architectures as well. And you can define all of them in one go, or like build me a package for app image, build me a package for snap as well, build me a package dab as well, build me RPM, and you can do that all in one go. So this is about the target that you want to export your app. Okay, then second thing is to keep in mind icons. So you want to define icon, you put it in a folder and you define that folder named icon, and that's where Electron Builder will pick your icons for your app. And if you miss to do that, then your app will be shown as a default Electron logo icon. So you don't want to do that, and which is why you define icons, and you define that in multiple sizes. So and these configurations, what sizes are required, you can find that in Electron Builder documentation. But for now, this is good enough. Even if you put just one PNG file, you are good to go. Now, another thing you may want to describe is the category of your application. So because developer diary was for productivity, so I defined category as productivity. So that can be used for the distribution platform that you want to distribute to. They might need this kind of information. It's optional. You may or may not skip this as you wish. Okay, so this is how the configuration for Electron Builder looks like, and how you pack. What command do you run to pack this app now? It's simply Electron-Builder. So make sure that you have, first of all, make sure that you have installed this dependency Electron Builder, and then you can run npm install. So your Electron Builder app, this library is installed, and then you can simply run Electron Builder this way. And one thing I like to do is I like to create a script in package, and which I name build. And there I mention this command Electron Builder. So every time I don't need to write this, rather I write npm run build. You might know these tricks already, so not going there. But it is as simple as this. You define Linux object, you define the target, and a couple of more things, and you run this command Electron Builder, and that's it. Your app will be packaged. One thing I would like to reiterate here is that you can build package for all distribution on a single platform or for Linux. If you are building app for Linux, packaging app for Linux, I would recommend you to do that on Linux only, whichever platform you choose. I chose Ubuntu, and I built all the packages from Ubuntu only. But don't try to do this from Windows or from Mac OS. In those cases, you might run into some errors, And mentioning this, that you can build all the distributions from one Linux distribution is important, because when you try to do this for other platforms, like building Windows app from a Linux system or building macOS from Linux system, you will run into challenges, lots of challenges. So the best way usually has been to build in the same system where for which you want to distribute. But in case of Linux, you can choose any of the platform. I have built in multiple formats like RPM, Pacman, FreeBSD, and I never run into any problems except APK. I was not able to make APK work. So that is something you might want to keep in your mind. So that was about packaging the app. Now you have this file which can be installed. If you have DAB, you can install that using dpkg. If you have RPM, you can install it on Fedora using RPM install command, and so on. So how do you distribute this with your target users? So the first thing is just share the file. That's it. So that's a direct distribution. Put up a website and then list your upload your this file, this packaged file there, and ask people to download from there. They will install from there. So that is the first distribution channel that I went. Then you see usually people will go for this distribution first and foremost. Benefit of this distribution channel is that you have control. You have all the complete control, that how you want to show, and you have analytics, and you know a lot more thing than you would if you had distributed on other channels. Now, an important part of distributing is not just the first time you share that file. What do you do after you release a new version? So your users, some of the users have downloaded your application. They started using it. Now you are shipping. You're shipping 1.1 or 1.12 or something. You are sending an update for security or for UI or for new features. Now, how do you get people to install your new app? So communicating with everyone, that's a long challenge. That's a challenge. And specifically, even if you have their contact details, you won't have their contact details. They will simply download the file and then they will install, and that's it, unless you have some sign up mechanism and so. But having said that, you want to enable auto updates. So people who have already installed your applications, can they get updates automatically? So when they are using, and then they will get notification that there is a new update, would you like to install it? And similar to what you might have seen if you have used Visual Code Studio, then you will see a notification that there is a new Visual Code Studio version is available. And when you click it, you install it, and then it works. So this also reminds me that Visual Studio Code is also built using Electron. So that is one of the best example that I can give, use of Electron to build a desktop application. Yes, as someone said, Visual Studio Code. Yes. So now enabling auto update. So one important thing to so Electron has this auto updater module in its library, which you can use to automatically update your application. Now, one important thing to keep in mind here is that it will work. This inbuilt module to update will work only for app image. That's it. If you have any other packaging, it won't work. So you are stuck there with inbuilt auto updating module. You can work only on app image on Linux. It works very well on Windows and Mac, or this auto update function, but on Linux it works only for app image. So remember that. And when you have so right now we are completely talking about app image only. That's it. So if you want to auto update your app image, first thing that you need to have is a release server where you host your files. You host your file, you host your update files there, and this is what your desktop application is going to communicate with when it wants to get a new version of the application. Now, there are multiple solutions. You don't need to sit and start coding your release server. Rather, there are already existing solutions available, such as Electron release server, Hazel, Nuts, or even you can use public GitHub releases to do this. The best solution that I personally like has been Electron release server. So you can, so you don't need, so you can maybe mention that if you are taking notes. Electron release server is something that worked for me, and probably it will for you. But you don't need to remember everything that I'm sharing in this talk, because I will share this presentation with you, and I have added proper links everywhere you might need to visit those sites. So one, for app image, you want to enable automatic updates. Now you have used Electron release servers to release server to create your server where you are hosting your files for your Linux app. And it's pretty simple. Simply just clone the repo, run it, and that's it. You have admin UI. You just upload your files there, and you name the version, and that's it. You don't need to do anything else. It's pretty quick. Now you have this release server. How do you get these updates from the release servers, from this client application, from this desktop application? And for that, I have included the code here. If it is too small, let me know. Right, Rice is sharing something. We will come to that very soon about Snap and everything. But for now, we are focusing on direct distribution. So we are talking about app image for now. And when you need to download updates for your app image, this is how the code looks like. Auto Updater is a module in Electron. So you import it from the Electron Auto Updater. And then we have an event on, which is an event update downloaded. If it is there, then you show a user a dialog, and I'm showing that you have a new version available. Would you like to apply those updates to your app? And once the user says yes, then it simply calls this auto updater.quit and install, and that's it. Your update has been applied. Nothing else. Simple 6, 7 lines, 10 or maybe 12 lines of code, and that's it. Your app had been installed earlier. It will be updated when you release a new version on your release server. So that was about the direct distribution. Okay, you're sharing the file directly with your target users. Now let's come to the second part of the distribution, which is external distribution. External distribution is where you are not controlling how it is being shared with your target users and how the updates are being applied. So you need to follow their rules, and you need to do some things. You need to modify, probably in some cases, to suit that distribution channel. Now I have divided these external distribution channels in two forms. One is the classic distribution. Classic distributions, I mean, they are quite focused on one Linux distro, one type of Linux system, while universal distribution are suitable for any type of Linux system or Linux distro. So for example, in classic distribution, we have DAB. We have DAB for Debian-based system. We have RPM for Rail-based system. Fedora is one of the popular. We have Pacman. We have Pacman for ARC-based systems. And then we have FreeBSD for FreeBSD systems. And then in universal distribution, we have three major choices. One, app image, another Snap, and the last one, Flatpak. So you convert, you distribute on these platforms. Only limited set of Linux users who have those particular type of distro will be able to install. And if you distribute here, almost all of the all of the Linux distro users will be able to use that. Now I'm sharing, and there is one more thing. You can actually convert these packages into one another that many of the Linux users might be knowing, but I consider that average user doesn't know this. And I have seen that people have run into problems when they convert these packages into from one package to another. So which is why discussing both of these is very important. Okay, now, right. Someone said that FreeBSD is using ports. That is right. Uh, so, but for now, we are talking about whatever we had. I think I'm not much sure about ports, and I have never used FreeBSD. But this, I'm sharing what I have shared with my target users. They asked me for some packaging, and I created those packagings for them. So let's talk about classic distributions first. So because that is kind of fundamental thing and is a has been for a long time. So you created a deb package. You can distribute, if you are directly distributing it with your target audience, they can simply go and type dpkig -i and then whatever is your name of your app and this deb file, and that's it. Yeah, the application will be installed. Now there is another thing that you can do, that you can distribute your own repository. So here there were two steps. One, they downloaded the file and then they run this command. And the second option I'm telling you is about distributing via or your own repository. So you add a repository and then you host your code there. You need to follow certain guidelines, and there are tools to do that. So, and I have included link here. So once you get this file, you can click on this and you will get to know that how to add, how to create your own repository and then store your dev file there. If you do that, then you can do simply like this. Two command lines. One, you add your repo. Your user has to add your repo to their sources list. And this is the command they can use: sudo add apt repository and whatever is your repo, and then simply apt install whatever is your name of your application. So this is much simpler than this, right? But then there is some added task that you need to do. Then third way to make this more usable, more accessible, is to distribute via Debian package repository. So if you are able to distribute, if you are able to add your package to Debian package repository, you don't need to do this one as well. You can simply, your users can simply go apt install developer diary, and that's it. You are done. Having said that, this was not possible for me, and this might not be possible for many of the people. There are restrictions to distribute on Debian package repository. So make sure to read about it. I have included the link. You will get to know about all the information, what are the restrictions, and how to build, how to distribute on Debian. But one restriction I would like to share with you is that if your app is not this, does not follow these three things, then you cannot publish on Debian. One, if it is not free, you cannot publish. If you do not allow users to modify the code, so the inherent condition is your code has to be open source. People should be able to see your source code and they should be able to modify it. If you are not allowing them to modify, you cannot publish on Debian. If you do not allow your users to distribute your code, your app, then you can again not distribute on Debian package repo. So these are the limitations that you have, and this process is going to be really long for you to distribute. I didn't go for this option because of all these challenges. Non-free, I think you cannot. I think you need to read this. There was an article exactly it talks about non-free as well. So you might want to go through this article for now. But for now, I just want to summarize and give you a high-level overview that how that these are there are some conditions, and it will take some time for you to distribute that. So I did not choose this. I went for just the first one, and probably very soon I will be distributing via my own repository as well. So this is what I would recommend as well, that first create dApp, and then whenever you have time, distribute via your own repository. And maybe when you have lots of users and you want to make it more accessible, probably is a good time to, and also you follow those license conditions that I just shared, then go for sharing on Debian package system. Okay, so now coming to more classical or classic distribution channels, RPM, Pacman, FreeBSD. If you have RPM package, then you can simply go RPM -I and then whatever the name of your app. And for RPM, you can also, again, similar to apt, you can choose yum. You can distribute via yum, and this way you can share on many of the rail-based systems, and that's much easier, I think. So yum install a developer ID is, I see many people prefer this over RPM, so it is a good idea to publish there as well. Now coming to other Linux distro, Pacman. If you are sharing on Pacman, Pacman -S, and this is and the app name. That's how you install. And similarly for FreeBSD, you can use pkg install, and so on. So those are simple. But how do you I never got requirement for people to say that they need the app to distribute on some catalog on Pacman or FreeBSD. So I never published there, and that's something up to you if you want to put in efforts there. But for me, the most important one, the Ubuntu, so distributing via Ubuntu and making it easier there. And then RPM was the second most channel that, and that also we saw in today's poll as well. So that was about classical distribution. Now coming to universal distribution, you publish on one distribution channel and it is available on all the Linux distro. How can you do that? So there are three main ways that I highlighted: AppImage, Snap, and Flatpak. So going through each of them one by one, and I'll just highlight few of the things that will help you make the decision where to invest your more of your energy. So first one is AppImage. Installing AppImage is that simple. There is nothing more simple than AppImage. You just click, you just bring your file to your system, and then you just click, that's it, and your app will run. Nothing else needed. Most easiest way to install any Linux application is AppImage, and which is available on almost all Linux distro. So that is the benefit of AppImage, that you do not have, and there is no extra step to publish. You don't need to do anything. For other distributions, we are going to see that you need to do something. Only then you will be able to find your applications in their distribution channel. AppImage, no extra step. And then another benefit is that you can support auto update out of the box. You don't need to do anything else to update. You don't need to set up a release. You don't need to rely on someone else's update system. Rather, you can build your own update release server, and then from there, automatically using the auto updater module of Electron, you can auto update your AppImage. So these are the benefits. Disadvantage: no desktop integration. So when it comes to creating shortcuts and pinning it to the bar and any desktop integration that you would want as an app user then those are not available to you. And this is a very serious disadvantage. Some people downloaded our app and then they just forget about it because they installed it in some folder, but then they couldn't find it anywhere. There was no shortcut. There was no tight integration with the desktop. So that was a huge problem. And specifically, it is for GNOME. For GNOME, you do not have this desktop integration. I think for free not a freebie. For KDE, you might see there is desktop integration, and then this this will vary for other distributions. Some will support desktop integration for AppImage, some will not. So quite confusing situation over there, and we can definitely say that universally you do not have desktop integration. You have for some, but not for all. Second big drawback was that you cannot auto start an app image, and that is true for again Genome. But for KDE, again, this is true that you can auto start. But again, we can see say that for all Linux distribution, you cannot auto start for all the distribution. You can do this for some, but not for all. Then third important point is security. So it's simply everything is packaged there. You just click run and then give it permission, and that's it. It will run your code. It's highly it's a very good solution to port your malware to different machines. But as a user, it is not a good idea. I wouldn't trust an app image. So, and also in other type of systems, they have some checks and balances which helps us increase security. In app image, none. So as a user, I wouldn't trust app image. And as a user, I will find it little bit, my experience won't be that good as I want it to be. And as an app developer, I simply skipped this. I supported app image earlier, and that was my primary way to distribute. But later on, because of these two limitations, specifically, I removed my focus from app image. It is available. You can download it if you want it, but my focus is not there. Okay. Now, second, Snap. So this is a very new thing for me, at least it was. It was new thing and very good experience, I would say. In terms of publishing, there was no effort in publishing to Snapcraft, and installing was quite easy. I just typed this command snap install developer ID and installed my app developer ID. And it was quite simple. It has also the versioning systems, so I can publish in beta channel, and then I have a stable channel, and a very good solution. So a couple of things that I like about Snap is that it provides sandboxing. So this adds an extra layer of security for users, and they can trust app they download from Snap more than they would download directly from a website or via app image. So that is one interesting thing about Sandbox. Then Delta updates, you are pushing another update to your application. You don't need to ship the complete code, rather just push the diff, and that's it. So it makes network request lighter, and the user experience becomes better. One disadvantage of Snapcraft I see is that its server is not open sourced. It is a centralized system. Snapcraft is centralized system. So this is one thing about Snapcraft that I didn't like. But other than that, I think Snapcraft is an amazing solution to distribute your app, and I think every developer should be publishing on Snap. At least this gives me. Okay, so I would want to wrap this up. We are talking a lot about distribution. So one quick thing I want to say is that Snap is a good solution, and you should publish on Snapcraft. You have everything to gain, nothing to lose. And Flatpak is also similar to Snap, but it is open source server side as well as the client side, and it is decentralized, which is another good thing. And then things are similar to Snap, like it has sandboxing feature, Delta updates feature, and the effort to publish is non-trivial. It's not as easy as Snap, but it's not that a big difference either. And you installation is also quite easy. Flatpak install FlatHub, and then whatever is the ID of your app, and you type it here, and that's it, done. It supports all these platforms. Many of the I can see almost all the platforms are supported, and same is the case with other like Snap. Also, this support most of the Linux distro. Now coming to comparison of universal distribution channel, I have actually shared with you already whatever I found important, but just to be extra sure, if let's say you do not have time or you just want to focus on one distribution channel, I have included this comparison table for you, where you can see differences between app image, snap, and flatpak. And this is thanks to the show source of app image GitHub repo. They created this comparison table, and it's quite good. Now, coming to another point, once you have built the app, you have to maintain your app. And this is, I think you will say, okay, Neil says that's weird distinction to make between low and non-trivial. Right. We will discuss that in Q&A. Maintain your app. So one thing that I didn't realize when I was starting to build Electron, that you have to maintain your app. And maintaining an Electron app is a task, is a chore. And there are some things that will help you make this task easier. One is always upgrade your Electron and Node version every quarter. Do not wait for 1 year, 2 year, or whenever you are releasing. Always upgrade your Electron on Node versions. Otherwise, your user will be stuck, such as it happened with me. My users couldn't log in. I had this Google login. And because I did not update this Electron version, which means essentially that the Chromium version that I was using, that was not updated, which means that when when someone is signing with Google, Google sees that this is coming from a browser which was quite old, and that might have some security issues. So Google did not allow user to sign in as a security measure. So it is always a good idea and in favor of your user that you upgrade your
Hello.
Electron. Yes.
Sorry for interrupting, but we are a little bit running out of time. So if you can wrap up.
Okay, just give me 2 minutes and I'll just wrap it up.
Sure, sure.
So there is just one more slide after this. Okay, so maintenance, always upgrade your Electron and Node versions every 3 months. And that's the ideal timeline that I found. Another thing is always test before packaging. So you have a good system in place to test your application, and you test it before packaging, you test it after packaging, and only then share it. I have made many mistakes, such as distributing a buggy application. Another thing is use TypeScript. When your code becomes big, which will absolutely, and I kept scratching my head when it happened, and it was a nightmare to change anything. It was nightmare to see that things are breaking. So solution could have been TypeScript. So I have started using TypeScript. Use that. Another is manage different version. If you want to manage different versions. Okay, so we will skip this part for now, and we will go to last final thing, which is analyzing and improving. So one particular insight that I have from my experience of last 4 years of building Electron app is that for Linux users Linux users expect privacy a lot than any other platform. So do not include any analytics service such as Google, or there are some external services. Do not use them. Rather, you can implement, but you still need analytics to improve. So how can, and the way I did was that I created simple bash file which takes the request logs to my server. So whenever my app loads, after some time it sends a request to update server. Do I have a new update for the app? And I log this request and I analyze those requests, and based on the unique IPs, I see that how many number of users do I have, how many number of returning users do I have, how much average time is spent. I'll share this script with you in a GitHub gist, and probably, or you can ask me for this on my Twitter, or this is how it looks like. It's a simple command to calculate downloads, simple regex. And okay, if you have any, you can reach me out on these channels, and I am open to questions.
Okay, there are some questions.
Yeah, but we don't have time, unfortunately. So it would be great if you could type down the answers, and we can leave the space for the next speaker.
Sounds great. Sounds great.
Thank you.
So thanks a lot, everyone, for joining in.
Okay, so moving ahead, our next speaker is Alexander Smith, if I pronounced it right, and he will be talking about fragmentation in open source world and the challenges to create a healthy and sustainable project maintenance.
Hi, Fagun. Can you please confirm you can hear me?
Yes, you're audible.
Great. So, hello everybody. My name is Alexander Zemke. I'm one of the developers, maintainers of the project called LabLot. So I'm going to talk about this project soon. And the title of my talk is on the fragmentation in the open source world and the challenges caused by this with respect to the maintenance of such projects. So let me start with, so let me see how to navigate here. Okay, so let me start with some general statements and considerations. So open source community, open source movement. So many people associate immediately, automatically contribution of millions of volunteers, many people across the whole world working, having the same or similar mindset, ideas and vision about how to develop the software, how to distribute it, how to make it available for the society. So there's a big amount of manpower across the whole world contributing to this movement. So while this is of course true for the whole movement in general, this is not necessarily true if you go down to the level of every single project. So we have many projects with a lot of manpower, and we have projects struggling to maintain the project in the long term. So there are different challenges for different projects of different sizes, and there's so like big projects have different problems compared to challenges you have if you maintain a smaller project, and there's for sure an overlap between these challenges. And so there's one important aspect or one important factor that is more critical for smaller projects. Okay, so in general, so if I talk about small project, it doesn't mean we are talking about a trivial project providing some trivial functionality. So if I talk about small or big project, I always refer to the amount of manpower available in this project. So the human factor related to the amount of manpower is more critical for smaller projects. So let me spend some time talking about this. So what many users think or assume usually is, okay, so there's a project I'm using, there's an application freely available, and if I have some feature requests or if I have some bug reports, so I report this, and then there's this expectation, okay, so there are people behind this project that will take care of this, they will implement this new feature, they will work out a fix, will provide the next update, and so on and so on. It goes like this more or less forever, okay, while I'm using this project. So there are always, while I'm using this application, there are always people behind this project who will make sure, you know, this project is still alive. And what people don't understand, not always understand, is maybe, you know, the developers and maintainers behind this project are human beings too. So most of us are working on this project in our free time, spare time, and it's getting more and more harder. So if your project gets bigger and bigger, again, bigger with respect to the feature set, so it's getting harder and harder for you to maintain such a project. So you have a limited amount of time. At some point in time, maintaining such a project becomes a work for you. So it starts maybe as a fun, as a pet hobby project, okay, and results in additional work for you. So you're getting more and more professional maybe with your project, and this basically adds on top of the usual stress you have in your life. So it's getting harder and harder, and then people also can have personal interests and motivations that change over time. So people can decide to stop working on this project. Okay, and if you don't make sure there's somebody who can pick up the work you did before, if there's nobody else who can continue working on this, the project is more or less done. Okay, so this situation is very, very critical for the smaller project where we don't have enough people attached to. So because of this reason, so it's very, very hard for these small projects to safeguard the maintenance, the reliability of the project in the long run. And so this is also my personal impression, so many developers in this open source community heavily underestimate the importance of the invest in the long-term maintenance. And I will talk about a couple of examples on the next slides. So one important problem or one important aspect here in this discussion is the fragmentation of resources or lack of collaboration between the different people working on similar projects. So instead of working together, let's say working together on the same project, combine the available resources that are spare anyway. People prefer to work on their hobby projects, and this is maybe successful for a couple of years, but then because of the reasons mentioned above, you don't manage to continue working anymore on this project. You stop doing this, and this is clearly not a healthy, sustainable situation for your project. So I would like to make these statements now more precise, to quantify them a bit, and I would like to do so by using the examples, by using the project I'm working on, and by using the examples for a couple of other projects that are similar to our project. So the project I'm working on is called Labplot. So for those who don't know this application, a very quick introduction about it. So Labplot is a KDE application for interactive graphic and analysis of scientific data. So this is just to get you a brief introduction, so you get an impression about what this kind of application can do for you. So this is an application following the graphical user interface approach. You can import the data into this application. We support multiple formats like ASCII, binary, multidimensional formats like HTML5, feeds, and so on and so on. So you import this data in the application, and you can prepare visualization of it. So we also support live data, meaning so you have data located somewhere in the hard disk or coming over the network from local network sockets, MQTT, or from serial port, and then you basically connect to these data sources, and application visualize the data for you on every data update, basically. So right now we support only two-dimensional visualization, and on top to the visualization we provide also multiple what we call analysis functions. Okay, analysis functions. This can be this can be either fitting, smoothing, fast Fourier transformation, interpolation, integration, differentiation of your data, and so on and so on. So we also provide some basic statistical capabilities. This is actually something, an area where we plan to add much more in the near future. So we also support access to different open source computer algebra systems, being Maxima, Octave, R, or also to dynamic script languages like Python and Julia. So with this, we basically allow to access a huge amount, a very, very powerful set of features provided by these systems. And once you're done with your analysis of data visualization, so you can export the results if needed to different formats, and you can embed them in your publication, and so on and so on. Okay, so this is a very brief overview of the feature set. So if you want to see more, visit our webpage. So here a couple of screenshots. So here you see a typical session of Labplot. This is the main window. On the left-hand side, you see the what we call Project Explorer, where all the objects you created in this project are shown, and then you basically click with the mouse, select an object, you get the content of this object basically shown in the middle area, in the main area of the application. On the right hand side, you can modify all the properties of the selected objects. So in this specific case, some data, some experimental data was imported in the application, and then we perform a fit by using a certain mathematical function. We perform a fit to this measured data. Okay, so this is how this application looks like, and then you can, once you are done, you can export the results. So here another example of what you can do with Labplot. Here we are plotting, we are visualizing a mathematical function defined via a certain parameterization. Okay, this is the so-called butterfly curve. Very, very nice example, and I wanted to use it here to show it here in this session too. So I mentioned the access to multiple computer algebra system, and this is how it looks like. So what you see here on the left-hand side is a notebook using Maxima. Maxima is a well-known open source computer algebra system, maybe the most powerful one in this area. And Of course, it's also possible to do visualization in these computer algebra systems, okay? But our approach is basically we do the calculation inside of such a computer algebra system session, and we expose the data, the results of these calculations, we expose this to the Leplot runtime, and then we basically can visualize the produced data, the results, by using our graphical interface. Okay, in this specific example, Duffing oscillator, the properties of the Duffing oscillator were calculated. So this is an oscillator that can develop a chaotic behavior, and then couple of relevant metrics describing this oscillator, this chaotic behavior, visualized on the right-hand side. Okay, enough of advertisement for Leplot. I hope you got an impression about what this project can do for you. And well, this is not the only project that can do this stuff, so I will introduce shortly a couple of other projects. So when talking about fragmentation of resources, and the amount of manpower you have attached to every single project, so somehow we need to quantify this, and I would like to quantify this by using the Git the commit statistics. So here I extracted the statistics from GitHub for our project and for the next projects I'm going to show soon. So what you see here is the history of Leplot in the last 10, 12 years. Okay, so you see, so the first two top contributors, so those are the, well, basically the two core maintainers of this project, and well, you see the number of commits every day or every week, whatever sampling is used here right now. So you see a constant active work done over multiple years. But again, so only two core developers right now. So we have a couple of other guys, so I'm showing here. So those are our students. So we are participating in the Google Summer of Code for multiple years already. We try to attract new contributors, new students, and by utilizing basically this program. So what you see here are our students. So this guy actually, I mentored him a couple of years ago, and then 1-2 years later, he became a GSOC mentor too. Okay, so this was kind of a success story for us. We managed to enable one person, and this person continued contributing to the project even after GSOC project was finalized. Okay, so this guy was mentoring these guys a couple of years later. So he disappeared then for 1, 2, 3 years because he need university was over. He was done with the university, and then you have your personal life. You need to organize a job. You need maybe to move to another city and so on and so on. So it took some time for him to finalize all this stuff. So he is now returning back, started contributing recently again. So we have a couple of other contributors. Let me show this here again. So a couple of GSOC students here. So this guy is actually one of our users who is quite active with respect to generating new ideas, but also providing fixes and also developing new features. Okay, this is of course an ideal situation when you manage to convert some of your users to contributors. Okay, so you see also this guy, please remember this name, you will see this name later on again. So this is one of the translators in KDE, at KDE, okay, and this is the person helping out all the time to make sure that the translation and localization relevant stuff is properly done in our code. Okay, so this is the situation for our project. Again, 2 core developers, sporadic contribution from other people, and well, this is the status of this project right now. We are not alone. Okay, so there are similar projects out there, and let me spend some time talking about them. So first of the projects I decided to pick here is SciDavis. SciDavis is an abbreviation standing for Scientific Data Analysis and Visualization. So actually the history of this project is quite interesting one. SciDavis resulted as a fork of another project that went closed source 15 years ago, so even 20 years ago. So I'm not going to talk about this project. And the 2 guys who forked this project, the original project, they quickly realized, okay, so the code base we have right now, this is maybe not in the best shape. We would like to rewrite everything, but this is a lot of work. Okay, so they quickly realized it's going to be hard. So you kind of understand the amount of the number of features you would like to provide. You understand the overall feature set that this kind of application needs to provide to the users in order to be accepted, in order to have a chance out there. And they quickly realized, okay, we need maybe to collaborate with somebody else. They started looking around and they found Labplot. Okay, at that point in time, Labplot had this transition from Q3 to Q4, major refactoring, major rewrite, and actually, so instead of adjusting, migrating the code, so we decided to start from scratch. Okay, we started from scratch, and the Side Davis guys decided to participate in this. So we used Labplot's repository. We used this new code where we tried to incorporate all the experience we had from the past, so everything that went wrong. So we wanted to do better. Okay, so we worked together for, I don't know, so maybe 1 year, 2 years. And then, so very, very healthy collaboration, very active phase for all of us. And then at some point in time, one of the Side Davis guys decided to quit this business. So he became demotivated. He had other activities in his life, so the motivation changed, interest changed, and he became demotivated because of the amount of work you need to do to invest here to get the project to a level where you would like to have it. Okay, you can, as I mentioned before, so the overall scope of such a project is very, very clear for all the people working on this project. So most of us have an academical background. So during our university time, PhD times, we worked, or we're still working with this kind of application. So you kind of know the overall feature set. Okay, now if you start implementing the features and you extrapolate to the level what you would like to see for your program, you can estimate the amount of time you need here. Okay, and this was one of the reasons for this guy to quit. So he said, no, I mean, it's taking too long of my time, too much of my time. It will take too long for all of us to become successful. I don't want to do this anymore. Okay, so he quitted this business, and a couple of months later, the second developer of Side Davis disappeared too. So the second guy didn't even notify us on the mailing list, so there was no personal email sent. He simply disappeared. Okay, not clear what happened to him, and well, at this point in time, Side Davis was quite popular on SourceForge. Popular with, in the sense of, so the number of downloads for this project per month was very, very high. And SourceForge didn't want this project to die because of its success. Okay, and then SourceForge did some advertisement on their homepage. So they started looking for another maintainer for this project, and there was one guy who decided to take over the maintenance here. So they joined this program, this project, took over basically everything, and yeah, so he became basically the maintainer of this project. A couple of months after this, we reached out to this, and there was maybe 1, 2, or 3 other guys who started working on this project too, because of all this advertisement and noise did by SourceForge. So there were multiple people who took over the work. So we reached out to them and asked for collaboration, asked to continue the successful and very productive collaboration we had with the original 2 authors of this project, and they didn't show too much of the interest. Okay, so for them, I mean, they were struggling with the overall amount of code and feature set of Side Davis anyway, and it was hard for them to move on now to yet another project. Well, so the project, I think, is still alive, but doesn't have any big development of new features. So there's more or less maintenance work, so keeping alive what was created in the last years. And yes, so maintenance is still done, but no major development done anymore. And what you see here, so there was some activity done by another user, and so this guy also disappeared here. 2016, so there was another guy who started contributing here and was not quite happy with the overall architecture of this code, so he decided to fork this project. Okay, like one of the problems in the open source community, so you don't talk to each other, you fork the project. Okay, I'm not saying this is always the case, but this happens from time to time. So this guy forked Cy Davis and created alpha plot. Okay, so this is now a screenshot and a statement, the description from this home from the homepage of this project. So this is how a typical session looks like in Cy Davis and alpha plot. So they have more or less the same feature set, and what is being done here, or what was done here, basically this guy decided to move to another plotting library here. So instead of using the code, the old library that was used by Cy Davis, he wanted to use something that is more modern, providing more features and having more maintenance and so on and so on. Okay, this is basically the refactoring done by this guy here, and then adding more and more features. Again, similar situation here. So quite some excitement and activity at the beginning. And this is what I always referring to. So it's very, very very easy to start a project. Okay, so you are very motivated, you are eager to develop something. It's very easy to do the first steps during this development, during this excitement phase. Okay, but then at some point in time you run into this saturation phase where it's not so easy anymore to do the next steps. Okay, you have technical challenges, you get challenges because of your personal life, because of the limited amount of time, and so on and so on. So all these factors I described in the beginning, so you run basically into these problems at some point in time. Okay, and this is what we see here. So after this excitement phase, after this very active development phase, it went down. So there was nothing done anymore, and then you see these different phases, you know, where this one single person finds where this person finds some time to contribute to. Okay, so big breaks in the development of this project. Again, some live shown here, and but more or less, you know, so one-man project to no further contribution from other people. So there's one more project to mention here. So this is called Views. I would say, you know, out of this project mentioned here, this is maybe the project with the biggest amount of feature sets, having also the longest history here, maybe. Also more or less a one-time project. Okay, this is a guy from academia who apparently has enough time to continue working on this project, working on this project already for many years. So the project is still active, still maintained. And a couple of years ago, so I reached out to this guy and asked for collaboration. Like, you know, so we are working on the same functionality. We are using Qt, you know, so there's a lot of stuff maybe to be shared. So let's come together, let's work together on something that is much bigger than compared to what we have right now in our projects while working alone on them. So this guy didn't show too much of an interest, you know, and then we went different ways, separate ways again, and continue working on our projects alone. So also here you see, so this is more or less one-man project. So one more project to mention here. It's actually another project from the KDE community. It's called KST. So this is also a project having a very long history, and this project is known for its speed. Okay, so the statement I took here is from their homepage. And you see here a typical session where some live data is visualized, so incoming data in high frequency is visualized, and then certain analysis functions like smoothing maybe is applied, you know, and then you get basically this kind of visualization. So let's check the activity for this project tool. So also here, more or less the same situation. We have 1 to 2 developers contributing to this project. So one developer who managed to work for a substantial amount of time, managed to contribute to this project, and he more or less disappeared 2 years ago. Okay, so right now there's nobody else who can pick up this project. So there are several emails sent to the mailing list, users asking for updates for some maintenance related work, for new builds for Windows, for new versions of Windows, and so on and so on. Okay, and there's more or less nobody who can reply, who can take over the work that was done by these guys here. Okay, there was another guy who was quite active, who has his active phase disappeared completely too. Okay, so right now this project is not, I would say, not alive anymore. Okay, as a short summary maybe, so what you see here, so for this kind of applications, we see a very fragmented distribution of development resources. So we see mostly 1 to 2 main projects, and these different projects have different speed of development. For Laptop, I would say right now we have a very, very active, very healthy development phase. So these 2 developers, including me, so I showed before, are working very well together. So it's a lot of fun developing, working together here. So we are, I would say, very, very productive, very, very effective right now. So there are no bigger discussions. So we are highly aligned, very productive mode right now. No conflicts. But it's clear, this won't go on forever because of the reasons I mentioned at the beginning. So we still need to think about what to do, how to do the project setup properly, so we don't run into the situation like for a couple of other projects I showed before. And also right now, so even being very effective, very productive, we are still very limited with respect to our time. Okay, so we know what, as I mentioned before, so we know very well what needs to be done, what we need to develop, what our users are expecting from us, also either by comparing ourselves with other similar open source projects or even with commercial projects that have a very, very big feature set. So we know pretty much what needs to be done here. Okay, and then we again kind of extrapolate the amount of time we would need here, and then we realize, okay, this will take us years, many years to get to this level. Okay, so somehow we would like to speed up this development. So being effective, being productive is not enough here. So the amount of manpower we have here is not enough to do the next steps. So we would like to bring the project to the next level, and having the resources available right now is maybe not enough. So we would like to change this current situation. So these challenges I mentioned before, so we would like to address them somehow. So we want to do the next step in the development of the project, and we want to make sure, so we have this healthy situation in the project going on for many years in future. So what we are doing here right now. So we are looking for synergies and collaboration with other projects. So with other projects, so I'm not referring anymore to the projects I mentioned before, because here the situation is clear. So they are either not active anymore, or we already reached out to them. There was no big interest to collaborate. Okay, so I don't think so. We are going to reach out to these guys again. So we are looking here basically for other projects or for other frameworks, libraries that we can utilize, that we can use in our application, that would help us to speed up basically the development of the project. So we also would like to intensify the activities within KDE, within our organization. So those activities are basically around packaging of the software, distributing it through various app stores like Microsoft Store, Apple Store, and so on and so on. So we have we would like, or we are already making more use of the build artifacts produced on the build infrastructure at KDE, like, so there's an installer provide nightly installer, nightly build. So there's installer provided for Windows, there's an image provided for Mac OS users, and we do a bit more advertisement around this build artifacts. We invite users to test, to use our nightly builds, not only on Linux, where the situation is more clear, right? So we also want to attract. So we realized actually, so we have many users coming from the Windows world, and we don't want to block them, don't want to completely ignore them. And now we are also inviting more and more of these users to test their nightly builds. Okay, and the results for this are produced on the centrally available infrastructure at KDE. So we also the documentation we have right now, this is definitely something that is not on the level where we would like to have it. And also here, so we are looking for some synergies, collaboration within the KDE organization. Yes, maybe I would like to make a short pause here. So I mentioned the infrastructure, built infrastructure. And so there are many people working behind the scenes, contributing to the success of our project or to the success of other projects at the KDE. So people are taking care of the built infrastructure, people taking care of the promotion work, documentation, translation, localization of the application, and so on and so on. You know, so these people are usually not the front men of the project, so they are not visible in many cases. Okay, but they are definitely there, and they're contributing a lot to the success of this project. And I think so all these guys deserve a lot of appreciation. So let me use maybe this opportunity to thank all these people working in these areas. So I really appreciate the help, guys, you are doing here. So Ben, Yuri, Paul, Carl, so many others doing their work behind the scenes. Thank you a lot. Same, of course, for the organizers of this event, so Alison and other people. So thank you a lot. So to improve the overall the current situation right now, so we also plan to increase the frequency of releases. So this is one of the problems we have right now, where we didn't pay enough attention maybe in the past. So we release when we consider the current new feature set to be big enough, and so there are no regular releases right now. So we do a release once per year, so less than a year maybe, and this is something that we definitely need to change. So we are releasing in big bunches, and we should do this a bit different. So we should release more frequently, and because releasing, getting additional attention to your projects anyway. So, and we want to invest more into the promotion work to attract new contributors. So having not enough resources, not enough contributors is a challenge for this kind of project, for the small projects. Okay, and this is definitely something we need to change by attracting new people to the project. So I mentioned synergies and working together, collaborating with other projects, and maybe just to give you one example. So what I'm showing here is Cantor. Cantor is another KDE application. It's a front end to different mathematical applications, to the different open source computer algebra systems like Maxima, Octave, and so on and so on. Okay, this is what I mentioned in the beginning, and this is one of the synergies, one of my examples I'm usually referring to in this context. So this is where we had a big additional value we added to Lab because of the collaboration between these two projects within KDE. So this is now another project where I'm contributing to, also mentoring GSOC students. So this is a standalone application, okay, but what we did basically, so we embedded the runtime, we embedded this application into LabPlot. We enabled this connection between the computational part of this application and the visualization part of LabPlot, okay, and then with this we basically enable completely new workflows and provide a big additional value to our application. Okay, so this kind of synergies, this kind of collaboration, this is what we are looking for here basically right now. I mentioned the promotional work. To be honest, so there's a certain change in the mindset happening on our side. Okay, so we plan to invest more in this direction now, and I don't want to say we completely ignored the promotional part in the past, okay, but I would say we heavily underestimated the impact or the importance of this promotional work. So somehow you have the impression, or you have this perception, you're writing the best code ever, so you're working on the most coolest features, so you're much better than your direct competitors, and so all these users you're trying to address, so they will automatically come to you. Okay, this is kind of a mindset we had in the past, okay, and this didn't go well. Okay, this was of course correct to a certain extent. Okay, we managed to attract a certain amount of users, okay, but this is not enough, and we didn't manage, so following this strategy, this philosophy, we didn't manage to attract any new contributors. Okay, so this is now something where we would like to change. So we started investing into the documentation, example, tutorials, and so on and so on. So this is something that was not didn't get enough attention from us in the past. We also invest now into the UX part of the application. So we need to make sure, you know, the application is not only usable by us, but also by many other newcomers here. So actually, there was a comment on one of the Reddit articles published by the KDE promotional team, and one of the users, the comment was like this: okay, so I installed Labplot, looks great, so the screenshots on the homepage look great, but I don't see how to visualize, how to import and visualize the data. Okay, and this was kind of a well, this was a very critical comment, at least for me, you know, so because you are working on this application for many, many years, and everything is very, very clear to you. So you know how to import the data, how to visualize, and you assume everything is very, very easy to understand. And then you are confronted with such a statement from a newcomer, from a new user, okay, and then you see, okay, people don't manage to work with your application right away. So you need additional help, okay? And this is something where we need something that we take very, very seriously and try to improve now. So the overall plan is, of course, to attract new contributors, to add, to convert. Ideally, we manage to convert some users of this application into contributors. So mostly the users in this community have the required technical background, so they have the technical skills, okay? And then if these people have already some skills in C++ and Qt area, so these people, of course, are very, very welcome here. And the overall goal, so without putting this now very, very negatively, so the final goal is to make yourself redundant. So what do I mean with this? So if some of us, if one of the co-developers decides to quit the project, okay, as it was the case for a couple of other examples I mentioned a couple of minutes ago. So if this person disappears for some reasons, okay, so there must be somebody else in this project, in this community, who can step in and take over basically what you were doing before. Okay, so it's like you know, so the hard disk in your computer. So if your hard disk crashes and if you don't have any backup, if you don't have any possibility to restore your data, to replace the hard disk, okay, your system is more or less done. And this is something that you can also apply the same arguments to the maintenance of such open source projects. So if you want to go long, if you want to have a healthy maintenance for a long period in time, you need to make sure there's somebody who can take over your activities. Of course, all these things mentioned here, this additional work into the promotion, documentation, and so on, this results in additional work and additional effort for the maintenance. As I mentioned before, you know, so 1-2 developers that need to do a lot of development, need to write hardcore code, so need to write a code that is not always trivial, okay, and then on top of this work, you need to also work out all the other points I mentioned above. So this basically results in additional work and effort for the maintenance, at least in the beginning, until you manage to organize additional manpower here. Okay, but without doing this additional work and without doing this additional effort, I simply don't see how to change the overall situation. So as I mentioned before, so right now, healthy situation, we continue working on the project, but it's clear to everybody, to all of us. So this can go on like this forever. There will be a point in time where we need to quit and where we need to hand over to somebody, and then there must be somebody who can take over these activities. At the end, it's now about finding the proper balance between doing the development work and finding enough time to do the promotional part of the project maintenance. So the last slide in my presentation, I mentioned multiple times, you know, we have not enough time, or you know, having enough time is a problem. It's a critical factor for people contributing to open source projects and projects having a non-trivial amount of features. So now we need to invest into the promotion. So finding time for the promotional work is a bit hard, and if you manage to find some time for this, so we want to be as effective as possible. Okay, so at the end, it's all about being more effective, using the time you have, and then producing the biggest output out of it. So what I'm showing here are 2 tweets from the last year. So in the past, we only published something on our homepage when we did a release. Okay, so there's a release announcement, so new release is available. We write a big blog post introducing all the new features available in the new release, and this strategy we decided to change. So now we basically report every couple of weeks on the current development activities. So if there's a new feature that landed in master, so we introduce this, so we prepare a new blog post, we tweet on Twitter, we with the help of the KDE promotion team, we distribute this information through multiple channels. And what you see here on the left hand side is a tweet published last year where we introduced a new feature that was finalized back then. So this feature was around this, what we call info element. Okay, with the help of this feature, it's possible to attach a label to your data point, and then this label basically keeps the position while zooming in, zooming out in the plot, while doing different navigation here, and then you can modify all the properties of this info element. Okay, so this kind of feature was introduced last year, finalized last year, and then we wanted to write an article about this. Okay, and usually, so we try to find a good example for the data visualizing our application. So in this concrete example, so I choose the data for the distribution of the hydrogen in our galaxy. So what you see here, so the 3 peaks are basically, so the measurement 21 centimeter emission line of the hydrogen is measured in a certain direction relative to our position, relative to our solar system. And as you know, so our galaxy has a spiral form, and into the direction where this measurement was done into, so we basically we probe this emission coming from the 3 spiral arms. Okay, because of this spiral arms having the different velocities because of the Doppler shift, so this emission line is shifted. Okay, and these 3 spikes you see, these 3 peaks you see here, basically they correspond to the 3 spiral arms of our galaxy that are visible from our solar system. Okay, so very, very nice example, very nice physics behind it. So I really liked this example. I was proud of it. Okay, I was really, really proud of it. And then on the next day, we produced another tweet. So this was kind of a fun tweet where I did a picture of my workspace of my desk. Okay, and then we invited our followers to a small quiz. So we asked to identify 12 KDE related things. So what you see on this picture is my cat. So he was a bit aggressive at this point in time. He aggressively refused to leave the desk. Okay, since I didn't have enough time for this activity, for this photo session, and I didn't want to escalate the situation even further, I decided to leave him on the desk and then do a picture with him. Okay. Well, this tweet with the cat brought us 4 times more attention, views, and impression on Twitter. Okay, so apparently having a tweet with a cat is more popular, more attractive than talking about the distribution of the hydrogen in your galaxy. Okay, so this is a lesson to learn from this, and maybe this is also the recommendation for everybody who is tweeting. Cats seems to be very, very popular on Twitter. So if you manage to incorporate cat in one of your tweets, attention impressions are guaranteed for you. Okay, so kind of a fun fact, and I think this is also the last slide in my presentation. So thank you everybody for your attention. So I think we still have some time for questions, and if you are watching the recording now and would like to reach out to us asking questions, so this is the link to our homepage. Multiple ways are documented there how to reach out to us, and I think so using our room on metrics and KDE's metrics is maybe the most easiest, most comfortable way to get in contact with us. Thanks, everybody.
Yeah, there is one question in the shared notes if you can take it.
Have you found any correlation between software internalization and code contribution? To be honest, not. I mean, of course, we know, so I mean, by checking the statistics, we know into which languages the software was was translated, and we have a couple of so at KD we have a couple of translators who are more active. Okay, so we have software. KDE software is translated in some languages, to a better extent compared to other languages. But this doesn't mean, so we have more contributors. Yeah, so we have maybe 1 or 2 persons doing this, and they simply have more time here. Okay, to do this work. And so with respect to coding, to writing code, I also don't see any relation, any correlation, any interdependence between the different languages internalization we are supporting and the code contribution. No. So this next question being written down right now: which activities did really help attract people to the project? So this year we started trying to quantify the success of this project, okay, by monitoring the number of downloads, checking statistics for Linux distribution, checking the number of downloads from the Microsoft Store, FlatHub repositories, and so on. Okay, so we are still in the process of defining metrics that we will use to quantify basically the success. Okay, right now I would say, so the personal impression is producing more noise around your project. So publishing something on the homepage, providing additional documentation, nice examples, and so on. This is what helped to attract new users. And right now we measure this basically by the number of personal emails we get by the user, number of bug reports, feature requests, and so on. So right now I would say the promotional work we did in the recent past brought us more attention, more new users than the new features we released recently. Okay, and this is the reason why I said, okay, so there's a certain change in the mindset happening right now, where we say now, okay, so the level of maturity of the project is maybe good enough now, and so the application is usable for many users coming from many different academical communities. So we simply need to reach out to them to introduce the project and try to attract new users. Okay, and this is what is happening right now. So we see new users coming and getting in contact with us. So promotion work definitely is had the heaviest impact in the recent past.
So I guess we can, there are no questions, so we can wrap the session here.
Thanks, thanks everybody. Bye-bye.
Okay, now we have a small break. We can, we'll continue after the break.
Hello everyone, and welcome back to the Linux App Summit. So next on the virtual stage, we have Jan Grulik. I hope to have the correct pronunciation, sorry about that. And he will give a talk about distribution of Qt apps to other platforms. So Jan, the stage is yours.
Okay, hello everyone. Just a quick check if you can hear me. Okay, perfect. So hello again. My name is Jan Grulich, and I will talk about distribution of Qt apps to other platforms. So first, let's start with some introduction. So I work for Red Hat, where I'm part of the desktop team, and my responsibilities there are to take care of Qt and KDE packages in RHEL. And besides that, I also try to include Red Hat's emerging technologies, such as Flatpak or Pipewire with KDE or Qt. And I'm also part of Fedora KDE SIG, where I occasionally package Qt and KDE. And I'm also a big fan of KDE and user and developer there. For example, I maintain the Plasma Network Management applet, so I contribute there as well. So about this presentation, so why am I giving this talk? Like a year ago, I took over maintainership of Fedora Media Writer. If you don't know Fedora Media Writer, that's a tool we provide to users. It allows them to easily download any Fedora variant and write the images to their USB drives. It has a nice UI and it's available on all platforms. And before that, I had zero experience building Qt applications on Mac and Windows. So I had to learn how to do that. The previous maintainer already had some build scripts written, but I introduced some new dependencies and I rewrote the application to CMake. So I had to learn everything, how to do that and update all the build scripts to include my new dependencies and to accommodate CMake changes and things like that. And it was not a really easy process to learn everything. It sometimes may get complicated. So I decided to give this talk. So I will mention tools we use to distribute Fedora Media Writer and to build it on Windows and macOS. I will give you some examples of CMake usage because that's something I learned recently during the rewrite. And it's not much about Linux because I guess many of you are Linux users and Linux developers, so you know how it works there. Okay. So let's start with some basics. Here I have just an overview of platform-specific defines you can use in CMake to distinguish platform-specific code. Each of the platform defines gets defined on the platform where you build your project. So there are defines like Apple, Win32, or Unix, which gets defined on each platform. With Unix, it can be tricky because Unix gets defined also on Apple. So in case you want to detect Linux, I use something like Unix and not Apple, for example. Then CMake also provides compiler defines if you want to distinguish, for example, between MinGW or Microsoft Visual Compiler. And I also include one tip for you because it's something that took me a while to figure out. When your application, for example, provides a QML plugin, this plugin has to be marked as a module, otherwise Qt on Windows won't be able to load it. That's a Windows-specific thing. It's mentioned in the documentation, but I didn't see it before, so I'm mentioning it here. So it might, because I think it might be useful for someone. And just to complete the topic, there are also Qt defines similar to CMake support I mentioned before. These are on the source code level and not on the build system level. So you can use these to distinguish your platform like Mac, Linux, or Windows. And same goes for all compilers. Okay, so now let's start with our first platform, and that will be Windows. So what everything you have to do for Windows? First of all, you might need to include a manifest file. The manifest file is in form of XML file and lets you define specific needs for your application. For example, in case of Fedora Media Writer, we use this to get some additional privileges because, as I mentioned, it writes the Fedora images to USB drives. So for that, we need special permission. But you can also, using that, you can also define another stuff like that your application is DPI aware or compatibility with other Windows versions and things like that. Then you probably want to create an installer for your users because probably you don't want your users to build your application themselves. And on Windows, the only way you can do that is to create an installer for them. And then you want to sign the installer. Otherwise, when users try to install your application, they will get warning it comes from unverified source. So therefore, we have to sign them. Okay, let's start with the first step, how to get Qt on Windows. So there are more options. You can get Qt from the official Qt installer. You can download it on the official Qt web page. Or the advantage of Windows is that you can cross-compile Windows application on Linux. So you can use min.gw packages. And that can also make your life simple as you can do it from one place. And in case you want some automated builds on GitHub, you can use this. You can include this action, which allows you to specify a Qt version you can use and the compiler you will use to build your Qt application. We use this to provide automated Windows build on GitHub. Okay, so let's start with the manifest file. So here I have example how to include the manifest file with your application. In CMake, you just use target sources, your target name, and path to RC file. The RC file might look like this one, where you specify the path or the name of the manifest file, which will get included into your binary, and then icon for your Windows application. And I think this works only for min.gw compiler. With the Microsoft Visual Studio compiler, if the Windows manifest matches the application or the target name, I think it includes it automatically. But I haven't tried that because we use the min.g compiler, min.gw compiler. And just to show you how the manifest file look like, this is the one we use in Fedora Media Writer. You can see we just require additional privileges for the write access. And when we are talking about CMake, one more tip for you. This is a specific thing to Windows. When building your Windows application, you have to specify its Win32 application. Otherwise, when you build it and start your application, it will automatically open the Windows terminal. And that's probably also something you don't want for your users to experience. So there are two ways, either in add executable command, you specify its Win32 application, or you can use set target properties on your target and set these properties to true. There are two ways. Now, when we build the application, we want to start preparing files for the installer. On Windows, you basically have to bundle or include all the libraries which are not present on the standard window installation. So that might include Qt plugins, QML modules, some system libraries. If you do this manually, you can, but in some cases, for example, in case of QML modules and Qt plugins, you have to make sure they will keep their directory hierarchy. Otherwise, Qt won't load them, and Qt libraries and system libraries can go to the root directory. But if you don't want to do that manually, which probably that's something you probably don't want because it's a painful process, we do that for some builds. But in GitHub, we use this way. You can use WinDeployQt. That's a tool Qt provides. When you run this tool, you specify QML directory and your application binary, and this will automatically install all your Qt plugins or all Qt libraries, and thanks to QML import scanner, it will also include all QML modules you need to bundle with your application. And system libraries still might need to be copied manually, because I think WinDeployQt is only about Qt stuff. So some things still have to be done manually. Okay, now we have all the files ready. So you probably want to start creating your installer. To create the Windows installer, we use ANSYS. It's an open source system to create Windows installer. It's script based, and it allows you to define everything you need for the installer, like files which get installed and uninstalled. You can define there the application name, version, link, things that gets into Windows register or the shortcut to the application. I don't have example how the script looks like because the one we have in Fedora Media Writer is quite long. But I think with this thing, it's something you probably copy from some other project and just modify it to your needs. So probably there is no reason to write this from scratch. And when you have when you wrote the script for the installer, you can try to generate it. To do so, you use make ANSYS tool. You can again get it from Ming GW packages on Linux, or you can use Chocolate on Windows. Chocolate is a package manager from Windows. So you can, if you have it, you can just run a choco install make ANSYS, and you are done. Once you create the installer for Windows, now it's time to sign the installer. To sign the installer, we use OSSL sign code. This is again from MinGW package. On Windows, there is sign tool, or basically a similar tool to this. The parameters or the command is very similar. So here I have example of the OSSL sign code we use in case of Fedora Media Writer. With the sign tool, it's similar. You specify the certificate, password to the certificate, you need the timestamp, and then specify path to the installer. Okay. And now, when you are done with the installer, it's time to try it. I don't think you will manage to successfully create the installer on the first try. I failed many times because many times you will find a library is missing, or I don't know, installer does something wrong. So this is like a try and repeat process many times. But if once you've managed to do it successfully one time, there's probably no reason why it shouldn't work in the future unless you add some new dependencies. There's probably no reason why it should break. Okay, now it's time for another platform, and it is macOS. With macOS, the situation is similar, but in some ways it's more complicated. The signing is more complex than on Windows, and the main disadvantage is that you have to do all of this on macOS platform. There is no cross-compiling from Linux. So you need some Mac machine, or probably install macOS to virtual machine at least. So on macOS, it's all about creating application bundle. Mac doesn't use installers. You can think of it as app image, where you ship your application together with all libraries, which are not available on standard Mac OS installation. Steps to create the bundle are following. You need to write info plist file, which I will describe later. Then you have to bundle all libraries, since this is similar to Windows. And after you bundle everything, you need to sign the binaries. You need to sign the bundle itself. Then you create a DMG file. And then Mac has an additional step. You have to send your bundle for notarization. I will describe all the steps more closely in next slides. So again, first step, how you can get Qt on macOS. What we use is Homebrew. That's similar to Chocolate on Windows. It's a package installer. So in our case, we just call brew install Qt 5 and brew install CMake. And it will give us everything we need. Another option is to, again, use the official installer from Qt. Okay, now we can start creating macOS bundle. So we start the process from CMake. With CMake, you define that your executable will be a macOS bundle, and you additionally can set icon to your application that you can see on the first line. Then we can specify some properties, like the name of the bundle. Then you specify path to info plist, and then you specify macOS deployment target. And you also can specify where the application icon can go, because the macOS bundles has some directory hierarchy. So things like icons or additional resources goes into resources folder. So now, what is the information property list? There's a file you have to include for every application bundle. It basically identifies your bundle. You can set there your application name, your version, icon. You can use your own template. It doesn't need to be the one that is provided by default by CMake. The format is XML. Here I have a small example. You can see it's key value based. So specify, for example, the icon file, and then the variable gets substituted from CMake defines. So you can, as I mentioned, you can either use your own file where you have your own application-specific defines. That's probably that's something we use in Fedora Media Writer. For example, for the version, we have Fedora Media Writer version, which gets substituted across the project. But you can use the one provided by CMake, but you have to know all the variables you have to define in order to properly get them substituted in the info plist file. Okay, now at this phase, we only have files or binaries which were built by our application. But as I mentioned, similar to Windows, you have to include all the libraries which are not present on standard Mac installation. So in this case, we use MacDeployQt. That's similar to WinDeployQt. It does basically the same. Here I have an example of how I use it with CMake. So you can see we first search for it, and then we create a custom command that calls the MacDeployQt, providing path to our application bundle, path to our QML directory, and application executable. Because on Mac, it's not very easy to bundle all libraries manually, like on Windows. Because if you for example see this example, when I call OTool on Qt GUI library, you can see the path to the library points somewhere to the system. And if you just blindly copy this library to your application bundle, it will keep pointing to the same path. And when you then distribute this to the users, they won't be able to load it because the path or the library on that path won't exist. So if there are situations where you have to do this manually, you have to change the path to the library. You first copy it to the specified directory in the application bundle. In this case, it's the name of the bundle, contents, and frameworks. And then you have to call install name tool. That's a tool that allows you to change the path to the library. And if you doing this manually for all the libraries is probably not something you want to do. So MacDeployQt will do all of that for you automatically. But there are some situations where some libraries might be skipped. We have this situation with Fedora Media Writer where some library is considered as a system library and therefore is not copied with MacDeployQt. So we have to do this process manually. Okay, now coming to signing binaries. With Mac, as I mentioned, there are two things. You have to sign all binaries in the bundle. That has to be every library in the frameworks directory, and then it has to be your application binaries or the executables. These all have to be signed, and then you also have to sign the bundle itself. To sign your application, you can use a code sign tool. Here's an example how it can be run. Or it can be done using MacDeployQt with code sign option. Then when you sign your application bundle and all the binaries, you have to create a DMG file. DMG file is a container for apps on macOS. As I mentioned before, you can think of it as an app image. To create one, you can use MacDeployQt again with the DMG option, or you can use AGI util. The example is here. So we call AGI util create and specify the application bundle name, the output, and some other parameters. And then the next step is notarization. This is specific to macOS, because on Windows you just sign the installer and that's it. Apple has additional step, that's notarization. The notarization process checks for any malicious code or components, and also verifies whether you signed everything correctly. This is done on Apple servers, so you send them your application bundle. They will then reply you, they will send you an email back with the result. Once again, you can use makedeploy, Qt to send your application to notarization, or you can use xcrun auto notarize app, then again specifying some parameters. Once the notarization is complete, you will receive back an email. The notarization produces a ticket that tells that your app is successfully notarized. Then you have to include this ticket within your application. So your distributed application is identified as notarized. Next time anyone wants to try to use it. And to include the ticket in the bundle, you just run xcrun stepper, the application name or the name of the bundle. It includes the ticket. And then you again create the DMG file, which you can finally distribute to your users. At this point, your application is properly signed, notarized, and you are done. Again, similar to Windows, that's probably something you won't make on first try. So again, this is try and repeat step many times. But again, once you do it one time and it works, and you know you have a way how to automate it, it's probably there is no reason when it should break until you introduce some new dependencies or anything like that. Okay, and that's it. Now it's time for some questions. Okay, I can see some questions in shared notes.
Yeah, also, there are some questions in the shared notes. I'm not sure if you want me to read them for you, if you can.
I can read them, I see them.
Okay, great.
First question, someone asking, I wrote the Qt application with Kirigami and K18N. While I'm struggling to varying extent to create builds for non-Linux platforms, I'm struggling the hardest to create a build for iOS. I know it's possible to do since Subsurface was ported to run there, but I cannot find any documentation on how to do it. What steps could one take to create this build? Okay, I saw this question before my talk. Honestly, I don't have any experience with iOS, but I would expect the build process or the bundling might be similar. So you probably have to bundle everything with your application. But as far as I know, on iOS, the only way how to distribute your application is through the App Store. So I have no experience how to get your application to App Store. Okay, second question. Where did you obtain the certificate for signing on Windows? I myself don't have a certificate for Windows or even for macOS. That's something our Fedora engineering does, the signing process. So they have the certificates, so they do the signing. Also, the packages are built in Koji, at least for the Windows build or the Windows installer. The package is built in Fedora infrastructure, and just get signed with the script we provide. Third question, how robust would you consider is MinGW for cross-compiling Windows versions from Linux compared to compiling natively from Windows? So I think for Qt, at least regarding Qt stuff, if you don't have some specific libraries, I would say it's robust enough. I think it has everything you need, all the tools. I haven't tried to actually build Fedora Media Writer natively on Windows. We built it natively in GitHub CI, but there we also use MinGW. So I haven't hit any issue with MinGW or anything I would like or I would be missing. At least for our usage. Another question: do you think you could run VSL to VSL to run the tools instead of MinG on Windows? I honestly don't know what VSL is. So yes, I think as I mentioned, for example, for the signing, there are alternatives. There was a talk on Thursday, similar talk to this one, just they didn't go that deep. They use the sign tool, for example, for Windows signing. They didn't use the MinG version. So yeah, all of this can be done using native Windows tools. Have you tried, another question, have you tried uploading your app to the Apple and Windows app stores? I have not. The only official way how we now provide a Fedora Media Writer is through the getfedora.org webpage. I once checked how to get your application on Windows Store. I don't think the process is easy because I saw that there were many steps in order to get their application there, and that's probably not worth the time. So at least in this case of Fedora Media Writer, I think the way how we provided the discoverability on the getfedora.org page is enough for our use case. Oh, I think I'm got the fourth question wrong. The Windows subsystem for Linux. That's the running Linux on Windows. Yeah, that's probably something that can be run instead of MinGW. But I haven't tried yet.
Right. Given that there is still some time left, maybe we can wait a few more minutes if someone else has questions. If you have, please add them in the shared notes.
if you decide to build your application on Windows and Mac, I think you can check how we do that in Fedora Meetup Writer. All the examples I mentioned here are from there, so you can see how we do it. You can see how we build it in GitHub CI, for example. That can be also helpful. We built in Fedora in GitHub CI. We built only unsigned binaries. The signing, as I said, is done by Fedora engineering. But you can even there you can see the scripts we use for signing. So you can check it there and get some examples. Yeah, there's another question. Have you seen the talk done by Dan and Aryan on Friday? Yeah, I saw it. I mentioned it during when answering one of the questions. Yeah, it was a great talk. They also built they also use GitHub CI to produce builds. It was for me. It was interesting to learn how to do the signing there and keep the certificates in private. That was a useful thing to know. Still, the signing because it's done by Fedora engineering, I probably won't have access to certificates, but it might be useful in future if we decide to somehow automate the builds and the signing. Because right now I have to open ticket for them and ask them to do the signing, to sign the builds I produced.
So if there are no more questions, I guess we can thank Jan for his talk. Thank you very much. Very, very interesting. Okay. And also thank you for taking time to reply to all the questions. And we will be
thank you for, sorry.
No, thank you.
I just wanted to say thank you for listening. And have a nice afternoon. Well, it depends on where you are located. In Europe, it's afternoon.
Thank you very much. We will be back in about 7 minutes with our next talk. So stay connected. Welcome back, everyone. I hope you enjoyed the break. Now we have our next speaker, which is Ruth Ikega. I hope I got her name right. With her talk, Contributing Beyond Code. For our attendees, please be reminded to ask your question in the shared notes so that we can read them at the end of the presentation. So let's give our speaker a few seconds to connect.
Can you hear me, Alison? Can you hear me? Can you hear me? I've got some connection issues.
Yes, we can hear you.
Okay, so I'll go ahead. Sorry about the delay. I've got some connection issues here on my computer. So hi everybody. Thank you for being in this session. So I'll be talking about contributing beyond code in GNOME. So my name is Ruth Ikega, and I'm a backend developer from Nigeria. I'm also a technical writer, and I'm also part of the GitHub program. And about not putting my video because of connection issues, my bandwidth, I have to not put on my video for now. Maybe during the questions, I'll try to put on my video. So, yeah. Okay, so in today's talk, I'm going to be taking you through my open source career ladder path and the challenges I encountered during contributing to open source, and what sparked my interest in while contributing, and also how you can help other newcomers and open source contributors and non-code contributors, because today I'm going to be focusing on non-code contributions, right? So sit right and let's enjoy the session. So let me tell you about my story into open source. So first, you should know that it's less than a year that I started doing open source contributions. I started doing open source contributions 3 months into my coding journey at July. So I'm going to be taking you through the story of all my open source contributions with the GNOME Foundation, and I hope you enjoy my story. So yeah, I started my open source contributions with the Women of Open Source Africa Challenge. So a quick context on what Women of Open Source Africa is. So Women of Open Source Africa is an initiative by the open source community here in Africa, and another group called another NGO called the She Code Africa, that is about contributing to the success of African women in tech. So the initiative came about in July, just launched in July, to make more women in Africa contribute to open source. Right, so there was the launch of the program, of the initiative, and there was like a little workshop to get you to contribute, give your first open source contribution. And I was 3 months into coding then. I have a microbiology degree. I transitioned from microbiology to doing tech. So I was 3 months into coding, and I said, okay, open source seems like a good thing for me to start on with. And before now, I'm also like a social volunteer. So volunteering has been something I am really passionate about. So I said, okay, I'm going to attend this. This launch for WOSCAR, that's Women of Open Source Africa. So I attended the launch. I think I attended it late, and during the workshop, I said, okay, let me give it a try. And we used the first contributions repository, one of the popular first repositories people do their first open source contributions with. So we used the first contributions repository to do a practice for the workshop. And I was struggling because I was trying to I had never used Git before. That was like my first Git experience. I'm going to tell you about my challenges with Git later on during the session. So I have never used Git before, and we were supposed to use Git. I had to download Git on my system and try to follow up with the conference. I was even jotting down while the speaker was trying to help us set up Git and everything. And I didn't even know how I made this contribution. You can see this is a screenshot of a tweet I made after making my pull request was merged, after making the pull request to add my name to the first contributions. So I immediately tweeted about this after I was able to send in a pull request for the first time, and it got so many engagements. Like you can see here, I had over 200 likes on this step of people telling me congratulations for making your first open source contribution. And I was so happy because I just basically added my name to the contributors list, and people were saying congratulations, and it was so nice. And I said, okay, I think I want to keep doing this. And fortunately, Women of Open Source Africa had a challenge in the month of July that was starting in the month of July. So it's similar to the Hacktober 1st challenge, where you get the criteria was get a good amount of pull requests merged, contribute to different organizations, and you're going to get a prize. So in the month of July, I put my head down to start looking for open source organizations that I could start contributing to. And it was really very hard for me at first because I just used Git for the first time, and I'm somebody that is very, very inquisitive. So I was like, okay, how am I going to start finding projects that I would contribute to? So let's go to how I found GNOME projects. So I want to take you through my engagement with GNOME. But first, I'll pause here and say thank you so much to Sri. Sri has been amazing. Like, Sri is the GNOME uncle. So he has been a very good mentor all through my contributions, both with GNOME and both with other organizations that I have been able to make impactful contributions to. So this is a shout out to Sri, and also a shout out to Peace Ojeme and also Samson Godi. They were very, very helpful with me finding the GNOME project, and I started my first contributions with the GNOME project. So I was just 3 months into coding. I was taking up Python classes, self-learning by myself. I tried to, I was looking for projects I could get involved with. And then at that time, the scalable onboarding project led by Sri was ongoing. And I joined the Jitsi room first. Like, that was my first time to hear about Jitsi. I only knew about Google Meet and Zoom. But when I joined the Jitsi room, on the first day of the meeting, I just stayed quiet to listen to everything. I felt lost, but then I had some courage, because they were willing to hear my opinions. I was coming into the call for the first time, and they asked for my opinions, and they wanted to know what I thought about the project, or there were questions, and I tried also to give my opinions, right? And then I was told we're going to be using GitLab, and I was only conversant with GitHub because, remember, I was 3 months into my coding journey. So I said, okay, I think I would have to make. I saw a change a change was needed on the README. So I was like, okay, I can make this change. And remember, I was on the Mosca challenge, right? I had to get some pull requests by the end of July. So I needed to start making my contributions. And I saw that the scalable onboarding project on GitLab, it had a README fix to be fixed. And I said, okay, let me try to contribute to this project by changing the typos on the README. And making my first contribution was an interesting and a frustrating one, because I struggled with Git and SSH. Like, I remember there was a particular night I did not sleep because I am somebody that is very eager. Like, I want to, if I start on something, I'm so eager to want to finish it. So I had to stay up all night trying to send in my change. I was struggling with setting up SSH and all the other things, but with the help of a friend, Okoye, I was able to push my change, and it got the first one. It was having so many errors, and I tried again the second day, and it went through. So basically, after making those README changes, I got involved with the calls and trying to set up this project. So the scalable onboarding project is basically, how do we make onboarding scalable? How do we improve the onboarding system in GNOME? So we're trying to set up all those. So I was fully involved with this project. Another project that I engaged with was the Faces of GNOME. So the Faces of GNOME was a website to appreciate the GNOME contributors, GNOME Foundation members, and I tried to do some overhaul on the documentation and seeing things I could improve. Then also another project that I'm also proud to be part of is the Extensions Rebooted initiative. So we are trying to make the extensions, GNOME extensions, trying to create that conversation between the GNOME developers and the extension developers, so that at every release, their extensions, GNOME extension, would not break. So all these projects that are listed here, even though I was not able to, I was still finding my way around coding, I was still able to meaningfully contribute to these projects. I was able to write on the Extensions Rebooted initiative. I was able to, write a blog post with together with Sri, and I was able to look at the documentation and try to see what I can do to make it better. So it goes beyond saying that open source is more than code, right? So let me talk about my challenges during contributing, because for non-code contributors there are so many challenges. So there are so many challenges that I encountered, even though it was a very good journey for me, even though it was really very sweet and very interesting. Let me tell you about the challenges I encountered contributing. So let's talk about my technical difficulties. So I told you earlier that I had some very, very, very crazy issues with Git. So I was using Git for the first time, and I think over time, over the period of 1 year, I would say everybody has Git problems, because till today I still have my issues with Git. But then starting was a whole lot more difficult, because I was just getting started, and Git was a whole lot for me. But then with trying to be consistent and with help I got from the community, I got better with using Git. Now, another technical difficulty I faced was, installing and setting up GNOME. I use a Windows operating system. So, finding how to set up and install was a big problem for me. It was so difficult for me. I know there were times where I had to read a lot of docs, I had to do a lot of things. And then network bandwidth. Here in my country, most times, the network is quite very poor. So joining the meetings, I had to, sometimes I would try to speak and nobody would be able to hear me, because my network was quite poor. And that's like an issue that most people, that is not like when you're not able to get good and better internet, you get to face this network bandwidth issues, right? And also I had electricity issues. There were some times where I needed to work with my laptop, but I did not have power to power my laptop. So sometimes it delayed my contributions and also my communications, and also sometimes it could delay my enthusiasm to continue. But then happily I still pushed forward. So communication difficulties. Now, I am from Africa and I'm from Nigeria. So I had the accent. Trying to hear when someone else is speaking was quite hard for me. Even when I tried to speak, also sometimes I would have to repeat myself over and over again for the other person to hear me. And it's normal, because accent differs. So I had to battle with a whole lot of this, but I had to try talking, because I am somebody that talks really fast. So I had to try pacing my words. I had to talk slowly so the other person will be able to clearly hear me. So there were also difficulties with me understanding technical and social terms that were unique to the GNOME project. So if during on the Rocket chat or on the chat channel, someone is talking about something that I was not conversant with, it was hard for me to understand these terms, because I was just starting. So I also had slack in communication, like with time zones, right? So initially when I started, I did not understand the time zone difference. So when I would send a message and there was no response in like 5 hours, I was like, oh, did this person not get my message? But then later on, I got to understand that that time zones differ, and it can be nighttime at the other end of the world, right? So now I have talked about my difficulties. I want to tell you about what I loved contributing, not just contributing code, but contributing beyond code. The community. There is so much to be done in the community. I saw beyond the software, right? I saw beyond because I saw people trying to understand the software. I saw beyond code and was able to contribute to the community, help in the community management, help with even not just with NOM, but with other organizations that I actively contribute to. I was part of the community management. I always try to look for ways I could help somebody else at the other end. I always try to look for ways I could, improve or promote people that were contributing. So I really love the community work and I will always be a community fan. Also, I try to create a niche for myself while contributing to open source. So I found out because of the difficulties I had contributing, I started advocating for beginners because I found out that in most open source projects, beginners are not well appreciated. And they're like, I saw that and I said, okay, well, I'll try my best in whatever community I find myself in, try to advocate for beginners, try to tell them you can get into open source because most people think it's just code, it's just about the software. But so many people do not know you can actually do other things. You can engage in community, you can engage in documentation. I also try to do public speaking to help others understand that yes, you can contribute to open source without having to write code, and also quality impact that he brought on the software. So a bit about this, I am part of the chaos badging project, and we are trying. What that badging project is about, it's giving diversity and inclusive badges to conferences that observe these metrics. So over time, contributing to that project, I was able to see how people would change their metrics to suit diverse cultures, right? So there's a lot of quality impact I was able to make, and I see them, and that makes me love open source contributions. Yes, there were rewards and recognitions. So with contributing to open source, right? I got a lot of recognitions, both from persons and both from organizations, right? Because these organizations I have been part of were really helpful to my growth. There were rewards for me. There were recognitions, which I'll talk about in the next slide. So one of the biggest rewards was becoming a GitHub star. So rewind back to when I said I'm barely 1 year. So June is going to make it 1 year of contributing to open source. And for my contributions and the impact I have made, the people I have inspired and have been able to educate, I became a year. And it was so amazing because I was like the first female from Africa, right? I was in the midst of three amazing male guys. So there were people that I have always looked up to, and getting that recognition meant a whole lot to me, and it's spurred me to keep contributing and to keep inspiring and educating others. And also recently I got some swags from Google Open Source. They recognized my contributions with no chaos, and they sent me some swags, which was pretty interesting because while I was unboxing those swags, I unboxed it with my parents, and they were so happy that I have been inspiring, I have been doing amazing things by myself, right? And also, I got an award as a GitHub star. So when the award came, it was so beautiful. It's so beautiful, rather, and it made me love more things about contributing to open source. Now, how can you help? How can you, create a more inclusive space for non-code contributors? How can you encourage more beginners to get involved in open source? Recognize and appreciate non-code contributions in your project or your community. So this is a call to action for you listening, for everybody listening to this talk. Recognize non-code contributions in your community, in your project. Set channels and pipelines to encourage non-code contributions. Appreciate them, and try to encourage their work. Try to put the spotlight on them. Open source is not just about code, right? Try to show empathy in your communications, in your engagement with non-code contributors, even generally while you're communicating, because it's a diverse team, and you do not understand. You might not know what the other person at the end of the at the other end is feeling at that moment. So please try to show empathy while you're communicating. And also, the most important thing I want you to take away from this session is recognize and appreciate non-code contributions. Set channels and pipelines to encourage those non-code contributions, and also to look at beginners coming into your project because they are helpful. Beginners see things from a different end, right? So try to encourage beginners that come into your project. Try to make things easier for them. Try to tell them, okay, if this is not your stack, if you can't write Python, you could contribute to documentation. You could help with community engagement. So this is a call out action to everybody that is listening presently to this talk and persons that are going to listen to this talk in future. So I'll take questions if there are any questions at this point.
Thank you very much for your talk. Very, very interesting. There's actually only one question in the short note. I'm not sure if someone else is writing right now. I know that there is someone texting in the chat. So I'm not sure if you can access the shared note, if you want me to read the question for you, or if you prefer to read it yourself.
Yeah. I'm trying to access it. It's still loading on my end, so you can try to read it to me.
So the first question is whether you have considered using a graphical interface to access Git.
Okay. So yes, I actually tried using the GitHub desktop, but there are some limitations to using on one of the projects I started contributing with. So you would always need to sign off your commits when you create a commit, and that was not available with GitHub desktop. So on that particular project, there was no way I could use GitHub desktop. So I had to stick with using Git. I think But definitely I still encourage beginners to also try out using the GitHub desktop too. So yeah, it works. Okay, is there any other question?
Yes.
Hope I was
So
able
there's
to
a
answer that.
second question, which is what are good channels to reach non-tech people? I suppose things like ERC and Gitter are still very tech focused, and so are issue lists on GitHub.
Okay, so channels to reach non-tech. So, Twitter, the tech community, first I'll talk about Twitter. The tech community on Twitter is one very active one. So, you could reach out non-tech people from, making call outs. If your project has a Twitter channel, you can do a call out and specifically state that you encourage non-code contributions, and encourage them to either send a DM or make it in the comments, and definitely you would get responses. And also maybe whenever you introduce your project in conferences or wherever you talk about your project, also put it there that there are different ways to contribute to your project. Non-code contributions are always welcome. So I trust that putting it out there, attracts whosoever wants to contribute without using code to contribute to the project.
There is also a third question, which is if you have a blog where people can read about your open source journey.
Sorry, can you repeat that question again?
Sure. So the question is asking whether you have a blog where people can read about your open source journey.
Yes, sure. I do have a blog and I'll paste it. Yes, I started, blogging was something that, helped me to learn more, because, contributing was, I had to, document my open source contribution. So I'm going to paste the link to my blog in the chat for anyone that wants to access. I particularly have a series to, that I dedicated to talking about my open source journey. So I'm going to paste that in the chat in a second.
I think we can wait a few more
Is there
seconds
any more questions?
and see if someone else has more questions.
Okay.
So guys, if you have any question, please write it down in the share note. Okay, there's a question coming in.
Okay.
So the question is, what are good arguments to convince people to contribute?
So first, I think I said something in the chat. So the is amazing. A good argument to contributing is document. First, can you look my contribution? Am I? Is it better now? Okay, back now. Sorry about that. So, encourage to contribute. Seeing documentation, because that's one of the first questions that, and now to get the project right. So, by good issues, right, projects, right, that quick fix issues. Those issues, try to make out and put enough right, enough context to what's implementable on the issue. So that problem, what to contribute, even the issue was open, right? Put it in context, say, okay, you can do this, you can reach out to me, you can, this is where you find this file, or to the necessary contributing files. So using you can also look at community management. Managing people that is really very, very hard, right? Contributing to also has helped me develop skills. So you can also try to talk about community management, how to manage chat channels to avoid misunderstandings and thereabouts. I hope I'm able to answer your question.
Yeah, thank you very much for your presentation. Thank you very much for taking time to reply to all the questions. So we managed to hear you. The connection, as you said, is not the best, but we managed to get it.
Thank you so much. I'm so sorry.
Thank you very much.
So yeah.
Thank you very much. So if there are no more questions coming in, I think we can take a break now, and we will be back at 1 p.m. UTC time for our sponsors office hours with the Fedora project. And there's still some slot for the BOF, so if you want to propose something, feel free. And there will be a panel discussion at 4 p.m. and then the last two talks for this year summit. So thank you everyone for being with us this morning, and see you later.